All right, so this is Algebra 2. We left off halfway through number 20. Today's date is Friday, December 13th, 2019. I'm going to do number 20 again, so I'm putting parentheses around these. Thank you, Colby. My bad. We left off on number 20. I'm putting parentheses around the first two terms and the last two terms, and I'm asking myself to factor out the greatest common factor. The greatest common factor is going to be 2 and 8. It's going to be 2. And then I choose the lowest number. That's going to be m squared. What's left over is m plus 4, and I need to add something else. So there's no greatest common for this one, no greatest common factor for m plus 4. But you still have to factor out something for factoring by grouping, so I'm going to factor out a 1 times m plus 4. Let me make it a little bit neater. If I do that, then I have 2m squared plus 1 times the quantity of m plus 4. And then I ask myself the question, can I factor either of these further? And it looks like this one could be, but no, it can't. And this one is linear term, so I'm done. Box it. Final answer. Number 21 is the same thing. Step 0 is always check if there is a greatest common factor. In this case, there is a greatest common factor. The greatest common factor is 2. So if I factor out 2, I'm left with 3b to the power of 3. Oh, wait, 2 is not a greatest common factor because I have 3 and 4. Okay, never mind. There is no greatest common factor in this case. Again, I'm doing the same steps. I put parentheses around the first two terms, last two terms, and I factor out the greatest common factor. Greatest common factor of 6 and 3 is 3. Greatest common factor of b to the power of 3 and b to the power of 2 is a smaller one, b to the power of 2. When I factor that out, I'm left with a 2b. I'm subtracting 3 minus 2. And when I factor out 3b squared from 3b squared, it's just 1, so plus 1. Over here, I have that minus sign still. Actually, I can consider the minus sign to be inside that parentheses. I need to get a 2b plus 1 in order to do correct factoring by grouping. 2b plus 1. In order to factor out something to get to 2b plus 1, I have to factor out a negative 2. A negative 2 times 2b is a negative 4b, and negative 2 times 1 is a negative 2. And then it's the same step again. I do 3b squared minus 2. That was the first term that we factor out of each, and then I'm left with the common group of 2b plus 1, and then I again ask myself, can I factor any further? And the answer in this case is no. I don't have any difference of squares or anything like that. On to number 22, unless someone puts up their hand to throw on the brakes. I don't see any hands. All right, number 22. This one, if this was just a linear term, like in parentheses, I don't know, p minus 7, I could use synthetic division, but because it's weird and it's only one monomial, I can just kind of set this into a fraction. So I can say it's going to be 3p to the power of 5 over 9p squared plus 5p to the power of 4 divided by 9p squared plus 27p to the power of 3 divided by 9p squared. I mean, it technically was originally one fraction, all divided by just one 9p squared, but I broke it up. I'm skipping a step here. Technically, this is just one fraction, and yeah, I split it up into 3 different fractions. And then I can go ahead and simplify. So 3 divided by 9, that's 1/3. So this is p something over 3. And then I'm asking myself, okay, now deal with the p. So p to the power of 5 divided by p to the power of 2. This is your properties, your rules of exponents. So I'm really doing 5 minus 2, and this is really p to the power of 3. So p to the power of 3 divided by 3 is the first fraction. The second fraction, 5 and 9, don't reduce, so I leave it as 5 and 9. But p to the power of 4 divided by p to the power of 2 is just p to the power of 2. Again, I subtract 4 minus 2, and I get 2. And finally, 27 divided by 9 is 3, so this is going to be plus 3p divided by just 1 on the bottom, so I can just leave that. And again, I'm doing 3 minus 2 to get 1, and if I just have p to the power of 1, I can just leave that as 3p. And that is my final answer. Box it. All right, raise your hand, ask questions, or slow me down. Otherwise, I'm moving on to 23. Yes?
So you divide the coefficients regularly, and then you subtract the exponents.
Yes, exactly. And that's kind of coming from our rules of exponents.
Oh, I found my card.
Nice. Where was it?
In all my track.
Oh, okay.
Putting out everything.
Well, thank you. It looks a lot nicer over there already. All right. So number 23 is a problem where I can use synthetic division. So synthetic division states that I'm going to flip the sign if it was, and I can only use synthetic division because this is a linear term, 1x minus 3. If it was 2x minus 3 or something, I wouldn't be able to do that. But on the final as well, I'm going to make sure that you can use synthetic division on at least one of these. This is a case where I can use synthetic division. Again, flip the sign to a positive 3. I put that in the top left, and I'm going to write down each coefficient. Question, Anna.
So you can only use synthetic division when there's two terms to divide by?
Yes, when you have a linear term. So x minus 3, I can use synthetic division. So if I have, in general, if I have x plus or minus any number, that's when you can have synthetic division.
Okay.
But never 2x, never x squared, never 3x squared, never anything like that.
Like with variables and exponents, you can't do synthetic with variables.
You can't have anything, yeah, you can't do synthetic division whenever you have an exponent like 2 in that case. All right, so are there any other questions, or I don't know if I answered your question fully, Anna. Do we understand that we can use synthetic division on this one and why I can't on this one? I have a squared on this one. Okay, and I also have a coefficient in front of the variable. I can't have a coefficient in front of the variable. I can only have a power of 1, and then this can be plus or minus 0. I could just have x, and I can still use synthetic division, as long as I just have a normal x there, or p in this case.
They both have to be like simple numbers.
If that's your way of thinking about it, that's okay. It's not very precise, saying simple numbers. You need to have a coefficient of 1, and you need to have a power of 1 on the variable, and then it doesn't matter if it's plus or minus anything. It could be just that, or it could be plus 3, minus 3. But the main condition is it. No, so I can't even do 3x with synthetic division because the coefficient is not 1. I can't use x squared because it needs to be the power of 1, and I definitely can't do 3x squared because both rules it's violating.
Okay. And what about the second term? Does that one have suffix?
This term, it has to be a number,
Okay.
or it could be 0. It could just not even exist, and you can assume it's 0.
Okay.
All right, so from there, we switch the sign, and I'm going to write down each and every one of these coefficients. In this case, it's not a coefficient, it's just the constant term. And be careful, if this didn't have any x squared term, you would have to assume it's a 0x squared. This one doesn't have a placeholder. You might have a placeholder type of question on the final. So make sure that you have this written in order where it descends in power. 3, then 2, then 1, then 0. There was no x term at all. If it skips 1, you need a placeholder value. Then I'm going to write down my coefficients: 6, negative 26, positive 34, and negative 29. Then I'm going to actually carry out the process of synthetic division, bring that 6 straight down, 6. Whenever we jump up to the top right, we have to multiply by 3. So 6 times 3 is 18. And then I subtract down again. I get negative 8. Multiply by 3 again, I get negative 20.
Because the negative, right?
Oh, say again?
You said subtract.
Oh.
Negative, right?
Well, I'm technically doing, they're opposite signs. One is negative, one is positive, so I'm subtracting them, I guess.
Adding though, like overall.
Yes, you're adding those two numbers. Yeah, sorry about the confusion. You're adding this number with this number, so you're technically subtracting. You're doing 18 minus 26. And then negative 8 is on the bottom. Negative 8 times 3 is negative 24. I'm going to add both of these two terms, and I'm going to get positive 10. Multiplying 10 by 3, I get 30. Perfect. You can put it in the hallway trash if you'd like. And then 30 and negative 29, both of these two terms add to positive 1. All right, so this last number is always the remainder. The way that I write my remainder is 1 over whatever I was dividing. In this case, 1 over x minus 3. If this number was 0, then you can kind of just ignore it. The next number is the constant term. Don't touch it. That is just the number 10. The next term is x. The next number is x squared. If I had another number, it would be x to the power 3. If I had another number, it would be x to the power 4, but I don't. So my final answer is just 6x squared minus 8x plus 10 plus 1 over x minus 3. And I can box that answer. All right, we're not distracting anyone. Anna, question.
So you kind of subtract x from each of them because it goes from 6x cubed to 6x
Yeah, it descends in power, exactly. It goes down in power. Or you get rid of an x, you divide out by an x. Oh, Control-Shift-C. All right, so we are on to number 24, unless anyone else has another question or wants me to slow down. Azuri, do you have a question? No? Question, India.
Why is there no x next to 10?
That is the constant term. So just the same way that 29 also doesn't have an x, the way that I descend in power is I go 3, then 2, then 1, and then nothing. Or x to the power of 0, which is 1. 1 times 29 is just 29. So it's really x to the power of 0. Yeah, good question. All right, moving on. We have number 24. We need to state if this binomial is a factor of this polynomial for each of these problems. The way that I'm going to do that, again, is using synthetic division. If this number over here was 0, then we can say, yes, it is a factor. In fact, there's a shortcut, and it's using, I don't even remember the name of the theorem, where it's basically saying, if I plug in the opposite, if I plug in -10 into each of these r's, and see if I get out 0 or not, that will also tell me if it is a factor. And that's the quickest way of doing this one. So yes, you could use synthetic division. It's almost the same amount of work, just slightly more work. Or I could skip a few steps and just plug in -10 to state if it is a factor. So we did learn that rule. We spent 2 days on it. It is in our notes, but I will state it again here as well. If I plug in -10 into r.
That's just like what the, like if that was r plus 6, you would plug in -6.
Exactly. So if I plug in the opposite, I guess. If I plug in -10 into r and get 0, that implies that it is a factor. So that's what we're using. I really wish it's like probably polynomial remainder theorem. That would be my guess. So that's what we're going to do. I'm plugging in -10. So I have -10 quantity cubed plus 4 times -10 quantity squared minus 56 times the quantity of -10 plus 40. I'm going to see if this is 0 or not. So -10 to the power of 3 is -1,000. I know that it's negative because anything to an odd power, so I can write another rule over here. Where do I have room? A negative to an odd power is a negative. A negative to an even power is a positive. So that's the shortcut that I'm knowing. Okay, yes, this is indeed a negative. All right, -10 to the power of 2. Well, a negative to an even power is positive. So I should have a positive 10 squared, which is 100. So I have 100 times 4. 4 times 100 is 400. Don't know what happened there. Come on, fix itself. There it goes. So this is going to be plus 400. I think it's okay. And then a -56 times -10 is positive 560. And then I need to also add on a 40. So, doing a little bit more math, 560 plus 40 is 600. So these two terms over here is 600. 600 plus 400 is 1,000, and 1,000 minus 1,000 is 0. So this one actually does equal 0. And then your conclusion, therefore, is yes. You can say yes, r plus 10 is a factor.
Do we need to write that out, or just say yes?
Or you can just say yes. All right, the same process yet again, Luria.
But if it equals 1,000, then why is it 0?
Say it a little bit louder, I couldn't hear you.
You said that if you add all those together, then it's 1,000. So then why is it 0?
Oh, just those right three equals 1,000. 1,000 and then plus -1,000 is 0.
Oh.
Yeah, sorry for the confusion. Other questions? And we're moving on to 25. So I'm doing the same thing yet again. I'm plugging in positive 10 and then I'm checking if it's 0 or not. So, and you might guess, well, if this one was 0, then this one was probably not 0. I'm probably going to put two of the same just to maybe mix it up. Or maybe I will do both 1 0 and 1 non-zero. Ellery?
If you're doing synthetic division, if it doesn't have a remainder, is it a factor? And if it does have a remainder, it's not.
Exactly, yes. So Ellery is asking, if this number is 0 right here, then it means it is a factor, and the answer is yes. If this number is anything other than 0, like 1, then that means it's not a factor. That means I had some remainder here. All right, so I'm going to use my shortcut again. I'm plugging in 10. So it's going to be 10 to the power of 3 minus 16 times 10 to the power of 2 plus 66 times 10 minus 63. All right, 10 to the power of 3, 1,000. 10 to the power of 2 is 100. 100 times 16, you just add on the 2 zeros, so minus 16 with 2 zeros. And then plus 66 with another 0, and then minus 63. And you can probably tell by this state the answer is impossible. It is impossible to be 0 because I have 63 and there's no other number to cancel out the fact that I have a 63. Like if I had maybe a positive 3 or another negative 7, maybe it could cancel out. But I have 0, 0, 0 for all the last digits, and then randomly 3. So right here, I'm going to take another shortcut and just say, no, it's impossible. No. And if you want to be very specific, you can say v minus 10 is not a factor. Yes, Anna?
So if we do the synthetic, is there a way we can avoid all those huge numbers?
You'll have the same huge numbers with synthetic division, but you'll have probably even bigger numbers because you'll have to add and subtract these. Well, I guess you're adding and subtracting them anyway. The reason I like the polynomial remainder theorem is because I can see right here that I don't even have to add or subtract. I can automatically say, no, it's not a factor. Question, Loretta.
So if they all end up in the same number, then a factor?
If all of these added up to 0, and if you want to use some trick that, yes, they're opposites of each other in the same number, then you can use those tricks. But the main thing is, do all of these numbers add up to 0? And if they don't, it's not a factor. I don't know if I answered your question. I feel like I just gave another rule. Okay. Number 26. Now we need to evaluate each function at the given value. So again, I'm just plugging in negative 3. So I plug in negative 3 into all of these, and I see what happens. So if I plug in negative 3, and by the way, we've now switched a unit, if you can't tell. This one was doing like polynomial remainder theorem, and now we're just doing straight on polynomials. Do you know how polynomials work? Can you plug in a number? And then down here, I'm going to say, okay, now find zeros. We're in that polynomial unit. Ellery.
With those plugging in ones, are you supposed to plug the negative 3 into the f of s?
It's that straightforward. Yeah, so I think I understand your question. F of negative 3, yes, you do technically say f of negative 3, and then is equal to all of these x's also get plugged into negative 3 to the power of 4.
Do you need to flip the sign?
You do not need to flip the sign. There's no polynomial remainder theorem. You only need to flip the sign because you need to plug in the 0. When you plug in the 0, you actually have to set this thing equal to 0, and then you say, okay, subtract 10 on both sides, minus 10. That's why we really were plugging in negative 10. So coming back down here, I'm literally just plugging in this value. I don't have to flip any sign. So negative 3 to the power of 4 plus 2 times negative 3 to the power of 3 plus 11 times negative 3 plus 4. And then I need to do the same type of math that I just did up above. So a negative to a positive power should be a positive number. So 3 to the power of 4. And Arrow just finished making the chart. It's kind of hard to see, but in the cabinet top left area, you should be able to see 3 to the power of 4. Oh yeah, 81. Positive 81, and then 3 to the power of 3 is 27. It's going to be a negative 27. Negative 27 times 2 is negative 54. And then 11 times negative 3 is negative 33, and then plus 4. So now I'm just going to simplify a little bit. What's the easiest thing to do? I'm probably going to deal with the negatives first. Both of those are negative. So both those middle terms, I'm going to leave the 81 plus 4 is 85. Again, 81 plus 4 is 85, and then these two negative numbers, I get negative 87. So negative 87. And now it's a lot easier. Oh, 85 minus 87 is negative 2. Final answer. So f of negative 3 is negative 2. You can write the f of negative 3 all throughout this if you'd like. The main thing is that you know that it's negative 2. All right, so moving on to number 27, unless someone wants to. Yes, Anna.
Can you just hold
Yep,
there?
I'll pause. You can give me the thumbs up when you're ready. Other people are probably writing this down as well.
Yeah.
By the way, why did you put this? Just so it looks nice. We're gonna hang some Christmas lights up.
Okay.
It's going to get very festive in here this upcoming week.
Yeah.
Does every desk get lights?
No, I just worry about my area.
Okay. Anna, that gives you permission to now ask him to clean his desk at a random time.
But I already cleaned it.
Oh yeah, no, like when your desk gets dirty,
Oh,
like
okay,
maybe
that's
in
fine.
January, she can ask you to clean your desk.
This one.
All right, so I'm plugging in -3 into each of these a's. So I'm saying f of -3, because even that a I'm plugging into, right? That means I'm finding -3 to the power of 3 minus -3 to the power of 2. And the parentheses here do matter, especially with these negatives. Minus 15 times -3 minus 16. Again, just plugging in all those -3s. And when I do that, -3 to the power of 3 is -27. -3 to the power of 2 is 9. But I still have this minus sign, so it's minus 9. -3 times this 15 is -15, and then double negative makes this a positive. Wait, 45. I don't know why I'm saying 15. 45, and then minus 16. I have to do some more math. I'm going to deal with, what's the easiest way to do this one? Well, 9 and 27, I like that one. That's -36. So I have -36 plus 45 minus 16. This is also nice because I'm always looking for like powers of 9. Everything is a power of 9. That's a power of 9. That's a power of 9 as well. So -36 and 45 is just 9. So this is now equal to 9 minus 16. And now our powers of 9 is ruined. 9 minus 16 is -7, and that is our final answer. You can say f of -3. F of -3 is equal to -7. Again, there is no calculator, which means there's lots of room to make mistakes. Unless, of course, you've worked it out with me ahead of schedule or at a private meeting that you get a calculator, in which case you get those calculators. I think you guys and girls know who you are. Find all the zeros for number 28. Zeros mean I set this equal to 0. You kill the, or don't kill, you substitute 0 in for the height. F of x is really asking, what is the height? What is the y-coordinate? And you say, oh yeah, the y-coordinate is 0. That's what it means to be a 0. And if you don't know what zeros are, I kind of talk about it up there on the poster by Oscar. This is 0 is equal to x to the power of 3. Actually, I'm going to pause because really what I'm going to need to do now is factor. I'm going to need to factor this right-hand side, so I might as well just start right now. Normally, I would rewrite the same thing, but that's kind of a waste of a line. Let's go ahead and factor this thing. I'm going to put parentheses, and I'm going to really add these two. So if I factor out the greatest common factor, again, I have 4 terms, so I'm factoring by grouping right now. I have 4 terms, and I'm going to factor out the greatest common factor of x squared. When I factor that out, I'm left with x minus 3. Now, this also needs to be an x minus 3 in order to be a similar group, right? It's factoring by grouping. It only works if I have the same group of x minus 3. So how do I get x minus 3? I factor out a -1. Because -1 times x is -x. A -1 times -3 is a +3. So that works out. And then again, factoring by grouping, the next step is saying that I group these. So x squared minus 1, that's my first, my terms that I factor out. And then my similar group here is x minus 3. So how many groups of x minus 3 do I have? I have x squared minus 1 of those groups. Question, Jaden.
How do you remember to do all these different kinds of problems?
Lots and lots and lots of practice. The same way that you'll learn it.
No, but like you just see it and then you're like, no, you're like, oh, I just...
If you ever have 4 terms, generally speaking, you're going to use factoring by
No, I'm
grouping.
not even talking about the problem. I'm just talking about how do you know how to do all of these, like how do you remember how to do every single one of these?
So think about how much work you're doing this year to try to memorize that stuff. Now multiply that. Now I've been teaching for 5 years. Multiply that amount of work by 5. That's how I've remembered. Yeah.
You just memorize all the formulas.
I mean, definitely my first year of doing this, I'm like, I might have to check my notes. But by that time, my first year, I have to not only learn it myself, but then teach it. So I'm essentially learning it twice. So multiply by 2, and you'll get some better memorization in. I still need to factor one more step because this can be factored. That is, what is it called, someone? It is a difference of squares. Difference of squares factors as a conjugate pair of x plus 1, x minus 1, and that's still being multiplied by x minus 3. All of that is still being set equal to 0, and now I'm going to use the zero product property. Zero product property states that each of these is set equal to 0, which means this says x plus 1 is equal to 0. This one says x minus 1 is equal to 0, and this says x minus 3 is equal to 0. That is the zero product property. Subtract 1 on both sides, I get x is equal to negative 1. Add 1 to both sides, x is equal to 1. Add 3 to both sides, x is equal to 3. Those are our three answers. Negative 1, 1, and positive 3.
Okay, we're writing it down.
Yeah, that's what I'm expecting. Yeah, you guys are doing a good job.
We're writing it
I figure that you guys are talking about math, or you're at least catching up with how to
down.
do the
It's
math.
good that you're thinking that,
But maybe
Just
not.
keep it like that.
Okay, we'll keep it like that. Keep doing the math. Good job, guys. All right, so again, I have 4 terms I need to factor by grouping. I'm going to change the f of x to a 0 because I'm finding the zeros. And I'm putting parentheses, 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 parentheses. 0 is equal to, factor out the greatest common factor. The greatest common factor in this case is x to the power of 3. What's left over when I factor out x to the power of 3 is x to the power of 1 plus 1. Again, x to the power of 3 divided by x to the power of 3 is 1. Then I need to make sure that I have the same group, so this needs to be an x plus 1. How do I get an x plus 1? Well, I have to definitely factor out an x to make that a 1. And I need to factor out a negative to make them both positive. So I factor out a negative x times quantity of x plus 1. And then again, I still have that 0 on the left-hand side. I have x to the power of 3 minus x. Oh my gosh, we missed a step, but it's fine. We can get it over here later. That times x plus 1. I could tell him, like, wait, there's still a greatest common factor here and here. And it's like, oh, that's because we forgot to do step 0. Step 0 was to find the greatest common factor over here. And the greatest common factor would have been x. But I can factor that out right now because the greatest common factor of that term, now that I've factored that factor in by grouping, is x. And I'm left with x times the quantity of x squared minus 1 times x plus 1. I will finish the video for number 29 after you guys leave for lunch. In fact, I'll just keep recording it right now. If you want to stay, you can. If you want to leave for lunch, you guys are dismissed. Yes.
I'll just ask you.
Later. Okay. Zero product property. I'm still setting this thing equal to 0. And now I have x is equal to 0. Or, oh, I have to factor one more time. I could technically set this equal to 0 as long as I remember to do a plus or minus whenever I do a square root, which we sometimes forget. So I'm just going to factor one more step further. This is a difference of squares, so it's x plus 1, x minus 1, and another x plus 1. There are 2 of these x plus 1s here and here. Set them each to 0. I say now that x is equal to 0, x plus 1 is equal to 0, x minus 1 is equal to 0, and x plus 1 is equal to 0. From there, I know that x is equal to 0, box it. X is equal to negative 1, box it. X is equal to 1, box it. And this is x is equal to negative 1, which we already got. Oop, x is equal to negative 1. So what we really have is x to the negative 1 with multiplicity of 2. Multiplicity of 2. That just says, hey, we got 2 of those answers. And that is our, I can kind of box that one right there as well. That's part of the answer. And that is our final answer for number 29.